Hello, hello. Can you hear me? You're on mute, I think.
Oh, hello.
Yeah, you can hear me, right?
Yes.
Okay, so we'll quickly discuss whatever I have done so far. These are the four questions. The first one is this. You said you got this, right?
Yeah.
So let's discuss it anyway. The point is that these are positive numbers satisfying this condition. What we will do is we can convert this inequality by using this substitution. If I use this substitution, the inequality that I have to prove becomes x cube plus y cube plus z cube is greater than equal to 3, right?
Yeah.
And this condition becomes 1 by x plus 1 by y plus 1 by z is equal to 3 by xyz, which basically means that xy plus yz plus zx is equal to 3,
Yeah.
right?
Yeah.
Now, if you look at this standard result, that x square plus y square plus z square minus xy minus yz minus zx, this is always greater than equal to 0.
Mm.
How do I
Oh,
know it? Because I know that this can be written as half of x minus y whole square plus y minus z whole square plus z minus x whole square.
yeah.
So
Yeah.
that is always greater than equal to 0. That is equal to this.
Yeah.
The reason I remember this is because this comes in this factorization, right? X cube. If I had a factorization like this, I know
Yeah.
that this is equal to x plus y plus z multiplied by this big thing.
Yeah.
So from here, we know that if I write it like this, x square plus y square plus z square is greater than xy plus yz plus zx. And if I had added plus 2 times xy plus yz plus zx on both sides. So this side will become 3 times, right?
Yeah.
So basically what you're getting is x square plus y square plus z square is greater than equal to 3 times xy plus yz plus zx. No, I am making a mistake. What we are getting is x square plus y square plus z square plus 2 times xy plus yz plus
Yeah.
zx is greater than equal to 3 times xy plus yz plus zx.
Yeah.
And this is simply x plus y plus z whole square.
Yes.
And we know from the condition that this is 3, so this is greater than equal to 9, which implies x plus y plus z is greater than equal to 3,
Yeah.
right?
Yeah.
So we have this condition, and we need to prove that x cube plus y cube plus z cube is also greater than equal to 3, right?
Yes.
So here, what we will use is something called power mean inequality. You can do a little bit of research on this power mean inequality. What it says is that we'll define nth power mean as this expression a1 power n plus a2 power n plus ak power n all divided by k and nth root.
Yeah.
So this is like the average of the nth power of some k numbers, and you are taking the nth root of that.
Yeah.
For example, if I do 2, this is like something called the standard, the variance, right?
Oh,
Like
yeah.
it's like average of mean square, right? A1
Yeah.
square plus A2 square plus AK square by K. You are doing the average of the squares, right?
Yeah.
And then doing a square root at the end.
Yeah.
And F3 would be similar. All the numbers you raise it to cubes, you do the average and then do a cube root at the end, right?
Yeah.
This is the definition of a power mean. F1, by the way, is the same as the arithmetic mean
Yeah.
because the square root will be your root 1, right? So it is the same thing.
Yeah.
The inequality says that Fn is greater than Fm if n is greater than m.
Um, okay.
So the higher the power mean you are taking, it is bigger than the lower power mean.
Yeah.
Okay. So you can check out the online proofs for it. There are many proofs for it, but you can easily verify it for small cases. And right now what we'll do is we'll use this inequality because now we can do a F3 greater than F1, something like that, right?
Yes.
If I do F3 and F1 for X, Y, Z, F3 should be cube root of X cube plus Y cube plus Z cube by 3, right?
Yeah.
Is greater than F1 is simply first root of X plus Y plus Z by 3, right?
Yeah.
But actually this is the same as X plus Y plus Z by 3, which is greater than 1, right?
Yes. Wait.
One second. Okay,
One.
I'll just write it on the next page. So basically what I'm saying is cube root of X cube plus Y cube plus Z cube by 3 should be greater than equal to the first root mean, right?
Yeah.
So if you cube both sides, what do you get? X cube plus Y cube plus Z cube by 3 is greater than equal to X plus Y plus Z whole cube by 27.
Yes.
And X plus Y plus Z whole cube. So basically now you can get this 3 this side and you get a 9 here, right?
Yeah.
Correct.
Yes.
And that is greater than equal to 3 cube by 9, right? Because we already showed that X plus Y plus Z is greater than equal to 3 earlier.
Yeah.
So that is
Oh.
equal to 27, not 3 cube by 27, it's 3 cube by 9. So it becomes 27 by 9 is equal to
Yeah.
3. So you're getting this thing is greater than equal to 3 for sure, if this is true. How did we
Yes.
get this? We got this by doing the x square plus y square plus z square is greater than xy plus yz plus zx and adding xy plus yz plus zx on both sides twice.
Yeah.
We knew the value of xy plus yz plus zx is 3. So you got x plus y plus z is greater than equal to 3, right?
Yeah.
And after that,
Oh.
this is directly F3 is greater than F1 in power mean inequality.
Yeah.
Because you just wrote this and cubed it and you got it, right?
Hmm.
You can use alternative ways to do it also, but this is an easy way to prove it. Okay. Note
Okay.
down the inequality power mean and try to see the proof of it. Okay.
Okay.
Let's go to the second question. The second question is about this regular polygon of n sides where all its diagonals are drawn in and there are light bulbs on each vertex. Initially, there are k bulbs on, right? So regular polygon, n sides, all diagonals are drawn. All diagonals are drawn. And by the way, he has mentioned in the question that you can even consider the sides of the polygon also as diagonals.
Yeah.
Sides are also considered as diagonals. Basically, any connection between any 2 points is counted,
Yeah.
right?
Yeah.
So the total number of connections in a regular polygon will be NC2, right?
Yeah.
NC2 diagonals, including the sides.
Yeah.
We have to make all the connections. right?
Yes.
You can see 10 connections here, right?
Yeah.
Now, in the question, he's saying that initially, so you have made the connections, there are light bulbs on each vertex. There is a light bulb on each vertex, so there will be 5 light bulbs, right?
Yes.
N bulbs are there, and out of which K of them are on. K are in the on state, right?
Yeah.
Now, what is he saying? Bob plays a game on this polygon. In each step of the game, he erases a diagonal and changes the state of one of the 2 light bulbs on the selected diagonal. Changes the state of one of the 2 light bulbs. Anytime you select a light bulb and select a diagonal, 2 light bulbs are connected to it. And when you erase this diagonal, you have to change the state of one of them.
Yeah.
Okay. And change the state means if it was on, it will come off. If it was off, it will become on. And you have to do that for one of the 2.
Yeah.
Okay. So this is the game. Determine all possible values of K for which it is possible for Bob to turn on all the light bulbs after having erased all the diagonals. So basically the situation should look like this. All the diagonals are gone and all the light bulbs are on.
Yeah.
All the diagonals means every side has gone. Everything is gone, right?
Yeah.
What are the possible values of K for which this happens, right?
Yeah.
So that is the question. So now let's think about it. We know there are NC2 number of edges, which means
Yeah.
diagonals plus sides, right?
Yes.
So our goal is to start with K bulbs on and end with N bulbs on, right?
Yeah.
Okay, fine. So let's think about it. Each time an edge is erased, exactly one bulb will change its state, right?
Yeah.
So once you have erased all the NC2 edges, the total number of state changes, total number of bulbs that change their state will be NC2 only.
Yeah.
That change their state should be NC2, right?
Yes.
Okay. Now focus on the vertices, okay? There are n vertices. Let's say xi is the number of times the bulb at vertex I was flipped. Number of times bulb at vertex I changed its state. Changed its state. Right?
Yeah.
Because the same bulb could be changed, the state could be changed multiple times because you select this diagonal or this diagonal or this diagonal or this diagonal, right?
Yeah.
Each time you might have a choice of changing the state of this vertex.
Hmm.
So xi is tracking what? This is vertex 1, vertex 2, vertex 3, vertex 4, vertex 5. So x1 tells us how many times this bulb changes state, right?
Yeah.
Okay. So now if you add up all the changes of state of all the bulbs, right? It should add up to the total number of changes of state, right?
Yeah.
So if you do summation of xi, where I goes from 1 to n, it should add up to nc2 right here.
Yeah.
Because actually this is the number of times you are changing state of any bulb, right?
Yeah.
Because you have to delete this many diagonals.
Yes.
Okay, so we have this connection. The sum of all the xi's is equal to nc2,
Yeah.
right? Okay,
Yeah.
now let's think about it. For a bulb to end in the on state, right? If it started from on, then it has to be flipped how many times?
An even
Even
amount of time.
number, right? Even number of times. And if it started from off, then it has to be flipped an odd number of times, right?
Yeah.
Okay, I'll write that in the next screen. So summation of I goes from 1 to n xi is equal to NC2, and there are K bulbs which started from the on state, right?
Yeah.
They can be flipped. Basically, to keep them on, they have to be flipped even number of times.
Yes.
And there are N minus K bulbs that were starting from the off state, and they have to be flipped odd number of times. Correct?
Yeah.
Okay. So, if you add up all the flips, right, the total number of flips should have the same parity as the sum of the flips for all of these types of bulbs, right?
Yes.
So basically, this is the total number of flips that happen to all the bulbs, right?
Mm.
Correct, no?
Yeah.
This should have the same parity if we add up the flips for the K bulbs even and this N minus K odd number of times, right?
Yeah.
Do you understand what I'm saying?
Yes.
So the sum of the flips for K bulbs that started on, they will always be even, right? Because you're doing even plus even plus even, right?
Yeah.
So basically there are K bulbs, each has been flipped even number of times, right? So the parity of this part of it is always even, right?
Yes.
And the N minus K bulbs, you are flipping each of them odd number of times, right?
Yeah.
So basically odd plus odd you are doing here, right?
Mm.
N minus K times, right?
Yeah.
Do you understand what I'm saying?
Yes.
If N minus K is odd, if N minus K is odd, then this sum is odd, right? This sum.
Yeah.
And if N minus K is even, then this sum is even.
Yes.
Correct?
Yes.
So finally, the total parity will be decided by this only, no?
Yeah.
Because if N minus K is odd, this sum is odd, and the total parity is odd, right? Then, correct?
Yeah.
But if N minus K is even, then this is also even, this is also even, total is even, right?
Yeah.
So what we can conclude from this is that the total number of flips, this thing, which was equal to NC2, NC2 should have same parity as N minus K, right?
Yeah.
Do you understand what I'm saying?
Mm.
I hope you're getting it.
Yeah.
When I say parity, what I mean is even odd.
Yeah.
Whatever is the nature of N minus K even odd, that will be the nature of NC2 also.
Yeah.
And
So
once we know this, then we can say K is congruent to N minus NC2, something like that, right? Mod 2.
mm,
Basically, what
um,
I'm saying is N into N minus 1 by 2, NC2, is congruent to N minus K modulo 2, right?
yes.
So from here we can say that K is congruent to N minus N into N minus 1 over 2 mod 2,
Yes.
right?
Yes.
Okay. So then we just have to do the cases of this. You can take different cases. It will be convenient if you use N as mod 4, all the cases mod 4.
Yeah. Yeah.
N is, let's say, 0 mod 4, right? In that
Yeah.
case, what is K, right? So 4K, think of 4K minus 4K into 4K minus 1 by 2, right? So notice that this is still even. So this is 0 mod 2 in that case, right?
Yes.
K is 0 mod 2, correct?
Yeah.
Now you can take N is 4K plus 1. In that case, what is coming for K? So 4K plus 1 minus 4k plus 1 into 4k by 2, right?
Yeah.
So this is 2k. So this is even number here, and this is odd number here, right?
Yes. Yes.
So odd minus even will be odd, right?
Yes.
So in this case, k is odd, correct?
Yeah.
In this case, k was even, by the way.
Yes.
Similarly, you can check the cases where 4k plus 2, right? N is 4k plus 2, right?
Yeah. Yeah.
In that case, you will get k is again odd.
Yeah.
You can check it out. So
Yeah.
basically, what we end up with is a table where n can be 0 mod 4, 1 mod 4, 2 mod 4, and 3 mod 4. And in those cases, k is even, odd, odd, and even. Even, odd, odd, or even.
Yeah.
If you select k like that, then automatically you will end up satisfying the condition that at the end all the light bulbs are on and all the diagonals are gone.
Hmm.
Do you understand what is happening?
Yes.
You just go step by step and check parity. You should realize that n minus k will have the same parity as nc2.
Yeah.
Okay, fine. Let's go to the next one.
So, so
Hmm.
is that all for the problem? Like you can use that as just the answer.
What?
So as the answer, you have the different parities of K for different models.
Different. See, n has only these four cases, no? All the four
Yeah.
modular residues with respect to 4, right?
Yeah.
So in all possible values of n, we have decided what has to happen for k, right?
Oh, okay.
The possible values of k are k has to be even for two different modulo 0 and 3 mod 4 when
Yeah.
n is, and when n is 1 and 2 mod 4, k must be odd.
Yeah.
Or as you can just say that k should have the same parity as n minus nc2, right?
Yeah.
When you do the cases of that, that's what we get,
Yeah.
right?
Yeah.
Okay. Question 3. Question 3, uh, the statement of it is a little confusing. Given point O and G, given a point O and G, given a point O and G, where O is circumcenter and G is centroid. They are saying find the largest value of D in terms of mod OG. Find largest value of D in terms of distance between centroid and circumcenter such that if ABC is a triangle with O and G as circumcenter and centroid of that triangle and circumradius R, then D should be less than R. So the thing is, if the points are fixed, point O and point G, technically you have fixed the distance between circumcenter and centroid, right?
Yeah.
So basically, there will be only very few triangles that will be possible. Like if you have fixed the distance, then it's not like any R is possible, right?
Yeah.
Like if you fix circumcenter and centroid, then it's not like you can draw arbitrary triangles, right?
Mm.
So what we have to figure out is ABC is a triangle whose circumcenter, centroid, and R is given. Oh, only circumcenter and centroid are given, and then you draw a triangle according to that.
Yeah.
And we have to make sure
Yeah.
that what is the largest value of D, and D is in terms of the distance OG, such that it is always less than R, right?
Yeah.
So the slight confusion here is like, what does he mean by D? Like, what is D really? So that is what I was wondering also. Like, what does he really mean by D? But so far, what I've thought here is, first of all, you need to just think about the relationship between the distance OG and the radius, circumradius R. Can you figure out a relationship between this and capital R for any triangle? Right? Because then only we will compare it. No, we'll say that this distance should be less than R and D can be represented in terms of OG and all, right? Correct?
Yeah.
So this is our first
Uh,
goal. For any triangle, if O and G are given, find the distance OG and try to relate it to the circumradius of the triangle. Okay? So here, what we will do is we will first understand a very famous result, which is about, it's called Leibniz theorem. I will show you. You should learn the proof of it also. So Leibniz theorem. And the theorem goes like this. It says it relate for any point P, for any point P in a triangle with, in a triangle ABC with centroid G, with centroid G. The theorem says this: PA square plus PB square plus PC square is equal to 3 times PG square plus 1 by 3 times A square plus B square plus C square, where A, B, small b, small c are the sides of the triangle, right? Now, what we will first do is understand the proof of this theorem or how to do this theorem, correct? And then
okay.
we will apply it to, we'll do a special case of this theorem where the point P is the circumcenter O.
Oh, okay.
So think about it. P could be any point in a triangle, right? So if you put point P as the circumcenter
Yeah.
O, then you will get what? OA square plus OB square plus OC square is equal to 3OG square plus 1 by 3 A square plus B square plus C square, right?
And the
And these are all capital R, right?
yeah.
So this is becoming 3 capital R square is equal to 3 OG square plus 1 by 3 A square plus B square plus C square, right?
Yeah.
And then what you're getting is OG square is equal to R square minus 1 by 9 A square plus B square plus C square. Correct? Right? Hello, are you there? Hello? Are you there now?
Yeah, I'm here.
Basically, what I was saying was if P was circumcenter O, then you get this, right?
Yes.
And then you will write this as 3r square is equal to this stuff.
Yeah.
And from there, we can solve for OG square, right?
Yeah.
And notice that this is a connection between OG and R, right?
Yeah.
So we will come to this later, but first we need to understand how come this theorem is coming, right? So we should know the
Okay.
proof of this theorem. There are many ways to prove it. One of the ways is vectors, and there is also complex number methods to prove it. But we'll see the vector method, okay? So let's think about it. So what we will do is we will say this is a triangle ABC, and we will choose a nice origin here, okay? So let's say P is the
Okay.
origin,
Okay.
correct? So the point P that you have chosen is the origin, okay? So this is 0, comma 0. Now from point P, the position vectors of A, B, C are this vector is A vector, this vector is B vector, and this vector is C vector. Are you understanding what I'm saying? Hello?
I don't think my connection
Hmm.
is struggling.
So what I'm saying is you will pick the point P as the origin, okay?
Yeah.
And the position vector of the vertices A, B, C from the origin, from P, are A vector, B vector, and C vector, right?
Yes.
This vector is A vector, this is B vector, this is C vector, right?
Yeah.
Now, the centroid, you should know that centroid of any triangle, if you know the position vectors of the three vertices, centroid is simply the sum, the average of it, right?
Mm.
Do you know
Mm.
normally if you know the vertices of a triangle, the centroid is x1 plus x2 plus x3 by 3, comma y1 plus y2 plus y3 by 3. Do you know that? Hello? Can you hear me?
Yeah. Yes.
What I'm saying is, do you
Um,
know that centroid can be written as this? Hello?
uh, I'm saying, no,
You don't know this fact.
no.
So suppose I give you a triangle. Suppose I have x1, comma y1, x2, comma y2, x3, comma y3 vertices. I want to find centroid, right?
Yeah.
So centroid will be the
Yeah.
line from median line, right? Two medians,
Yeah.
correct? So what is the midpoint
Yeah.
here?
Um, x2 plus x3 over 2 and
Correct.
y2. Yeah.
So this point we know D is simply this coordinate, right?
Yes.
And this is A, let's say. So don't you know that
Yeah.
centroid will divide the line median in the ratio 2:1?
Yes.
So can we do section formula and find the vertices of G now? Since I know vertices of A and D, can I find G?
Oh yeah.
So I will do
Yes.
2 times of x coordinate of D, which is x2 plus x3 by 2, plus 1
Yeah.
time of x coordinate of A, which is x1, whole divided by 2 plus 1, right?
Yes.
So see what is coming
Oh, yeah. X1 plus x2 plus x3
by 3.
over 3.
Similarly for y1 plus y2 plus y3 by 3 also, right?
Yeah. Yeah.
Anytime we talk about vectors, a position vector is basically x1 I cap plus y1 j cap. No, that's nothing different.
Yes.
Similarly, x2 I cap, y2 j cap, x3 I cap, y3 j cap. So similarly, the G centroid's position vector will also come like x1 plus x2 plus x3 y3 and all. No?
Yes.
Position vector is just another way to say the coordinates that I have shown, right?
Yeah.
So
Yeah.
the same result will be valid for that also. So centroid's vector can be written as the sum of the vertices vectors by 3,
Okay.
right?
Yes.
So now what we need is something like PA square, PB square, PC square, something like that, right?
Yes.
So PA is like the distance from here to here, but that is same as mod of the vector, right?
Yes.
So PA square is like mod of vector A square plus mod of vector B square plus mod of vector C square. This is like PA square plus PB square plus PC square,
Yes.
right? And
Yeah.
what we need is to connect it to PG square and all, right? For our
Yes.
Leibniz theorem, right?
Yeah.
Okay. So PG, this is the G coordinate. G vector is A plus B plus C by 3, right?
Yes.
So if I need P to G, it is like from origin to G. So what I need is G dot G because that is going to be mod of G square, right?
Yes.
Centroid is somewhere here. This is G. So this vector's length I need, right? PG square.
Yes.
So that is like mod of G square because P is the origin.
Yeah.
So when I do that, I have to do A plus B plus C by 3 dot product with itself. A plus B plus C by 3, right? So it
Yes.
becomes 1 by 9. And now A dot A is mod A square. Similarly, mod B square plus mod C square. But you also get extra terms with like A dot B and B dot A, right?
Yeah.
So you get 2 times A dot B plus 2 times B dot C plus 2 times C dot A.
Yeah.
So this is my PG square, by the way. PG square is equal to this, right?
Yeah.
Okay, fine. Now, then we can write 9 times PG square, 9 PG square is equal to mod A square plus mod B square plus mod C square plus 2 times A dot B plus 2 times B dot C plus 2 times C dot A, right?
Yeah.
And this stuff is my PA square, PB square, PC square.
Yes.
So I'm already very close to my thing. I just need to understand what is this, right?
Mm.
Okay. So now think about the side length of any side here. For example, AB side. AB vector would be uh, A minus B
Yeah.
because this is my A vector, this is my B vector. So B vector plus something should be A, right?
Yes.
So that something should be A minus B, right?
Yeah.
So if I want mod of AB, I need to do mod of A minus B. One way to do it is do dot product of this vector with itself. So you'll get mod of AB vector dot AB vector is equal to mod of AB square is equal to A minus B dot with A minus B, right?
Yeah.
And that is going to become mod of A square plus mod of B square minus 2 times A dot B, right?
Yeah.
So now I know that 2 times A dot B I can isolate. 2 times A dot B is equal to AB square minus A square minus B square, right?
Yes.
Correct?
Yes.
So similarly, 2 times B dot C will be BC square minus mod B square minus mod C square, right?
Oh, yeah.
So I will replace all of them here. So see what I'm getting? I'm getting AB square plus BC square plus CA square. And each time I have two of these negatives, right?
Yeah.
So it will become 3 mod A square, 3 mod B square, 3 mod C square negative, right?
Yes.
And there is a plus 1 time. So I'll end up with minus 2 mod A square, minus 2 mod B square, minus 2 mod C square, right?
Yeah.
Right.
Yes.
So notice that this was the length PA, PB, PC and all, right?
Yes.
And mod AB and all are the side lengths of the triangle, right?
Yeah.
So this is like C square, A square, B square, and this is like minus 2 PA square, minus 2 PB square, minus 2 PC square, right?
Yeah.
Correct.
Yes.
So what I'm getting is finally 9 PG square is equal to A square plus B square plus C square minus 2 PA square plus PB square plus PC square, right?
Yeah.
Something like this I'm getting, right?
Mm.
Okay. So, uh, 1 second. Okay, I have made some silly mistake somewhere, so I'll just do it again. So my 9 PG square was what? 9 PG square earlier was mod of A square plus mod of B square plus mod of C square and plus 2, it was plus 2 A dot B plus B dot C plus C dot A.
Yeah.
I made a mistake by subtracting, it was plus. So
Oh.
now what I have known is 2 A dot B has come out to be 2 A dot B and all has come out to be A square mod A square plus mod B square minus C square, where this C is the side length,
Oh, yeah.
right?
Yeah.
So similarly, when I do for each of the terms, what I will get is uh, 3 times A square and also 6 times will become.
Mm.
1 second. So what I get is oh, it is not 2. The 2 itself is included in this, so I don't have to do anything. It is simply like this: A square plus B square minus C square plus B square plus C square minus A square plus C square plus A square minus B square. Something like this is coming, right?
Mm.
Because the
Yeah.
2AB itself is included. I don't have to double it. So what
Yeah.
you will get is 9pg square is equal to, there are two a squares like this coming. So 3a square plus b square plus c square. By the way, these A, B, C refer to PA, PB, PC vector lengths, right?
Yeah.
And this C and A and B are sides. So you're getting
Yeah.
minus A square plus B square plus C square, which is side length of the triangle, right?
Mm.
So you're getting PG square is equal to 1 by 3 PA square plus PB square plus PC square minus 1 by 9 A square plus B square plus C square.
Yeah.
Now you put P as the O and you get OG square is equal to 1 by 3 into 3R square, right? Correct.
Yeah.
Now you put P is the circumcenter and then PA square plus PB square plus PC square becomes 3R square.
Mm.
Are you understanding?
Yeah.
If you are still confused, you can search online and find a proof of Leibniz theorem. You will get the vector proof. Okay.
Okay.
Just find that proof. So right now what we have is OG square we are getting in terms of R square minus A square plus B square plus C square by 9, right?
Yeah.
Now, what can we say now?
Mhm.
So,
Doesn't this mean that R is always greater than OG squared?
one
R is always
second.
greater than OG?
This means that R is greater than OG for sure. But the question was saying condition D less than R must hold for any triangle, right?
Yes. But we've shown that's always true.
1 second, hold on. Hmm. So let me think what we can say here. Um, can we say hmm, right now we have OG is less than equal to R, right? Because OG square is equal to R square minus 1 by 9 A square plus B square plus C square.
Yeah.
But we want a condition on it. So for an equilateral triangle, what is the relation between OG and R? Let's think about it. If the triangle was equilateral, we would have OG square is equal to R square minus A square 3A square. So A square by 3. And in an equilateral triangle, centroid and median, all of them are the same points. So
Yeah.
this is the, no, this is the R. So this is A by 2. This is 30. So R is how much? You can say sine 30. No, cos 30. Root 3
Yeah.
by 2 is equal to A by 2 by R, right?
Yeah.
So R is equal to uh, A by root 3, right?
Yeah.
So if R is A by root 3 and centroid and okay, so this distance is 0. Okay, that makes sense because now this distance is vanishing for equilateral, right?
Yeah.
So A by root 3 square is equal to A square by 3. So fine, yeah. So in that case, OG, okay, also OG is greater than equal to 0, we know, right? Equality to
Yeah.
0 happens in equilateral, right?
Yeah.
So I want a bound for OG. So
What if you make it like a degenerate triangle?
so 1 second.
That's what I tried.
Can I say OG is less than equal to R by 3? I don't think this is correct.
When I tried a degenerate triangle, I
Hmm.
got that OG is a half off.
OG is?
A half off, but I don't know if it's true.
No, so see, O, 9-point center, centroid, and circumcenter. No, this is orthocenter. Orthocenter, 9-point center, centroid, circumcenter. In our problem, this is the distance, right?
Yeah.
In our problem, this is the OG,
Yeah.
right? But
Yeah.
we know that this is all of these points lie on a line. It's called the Euler line.
Yeah.
And there are some properties of this line, like the ratio in which G divides the orthocenter and circumcenter is 2 is to 1,
Yeah.
right?
Yeah.
So technically you can say the distance OG is equal to 1 by 3 of the distance OC, OH,
Yeah.
if you call this as orthocenter as H,
Yeah.
right?
Yeah.
So we can find the distance between circumcenter and orthocenter directly. Uh, and OG will be 1/3 of that, right?
Yeah.
Okay. Uh, but I don't know whether you'll get a condition from it or not. 1 second. So if a random triangle is there, A, B, C, orthocenter is here, H, and circumcenter is here, O. I want this distance. So you can find it actually by looking at this triangle, because this triangle, this is R, and this distance we can actually find, or actually we know this distance because it is C here cos B. No, C cos this angle. No,
Hmm.
no, it is correct only, C cos B. Think about it, C is this and this is B, right?
Oh, yeah.
In this right angle triangle, this is C cos B, right?
Yes.
So if this is C cos B, but I need BH, okay? That's what I want, BH. So let's think about it. Okay, so if I extend it like this angle is A, so this much must be 90 minus A.
Yeah.
So 90 minus A, and I know the if this is 90 minus A, I know this angle is, okay, I'll find it now. This angle is B minus 90 minus A, right?
Yeah.
So that is A plus B minus 90.
Okay.
So that is 180 minus C minus 90, right?
Oh, yes.
So this angle is 90 minus C, no?
Yeah.
So I have a small triangle like this where this angle is 90 minus C. And I know this is C cos B, right?
Yeah.
So I can find this now,
Oh,
correct?
yeah.
So how do I find it? I do cos of 90 minus C, base by hypotenuse, right?
Yeah.
Sin C, cos of 90 minus C sin C is equal to C cos B by X, right? So X
Mm,
is equal to C cos B by sin C.
yeah.
And by sine rule, A by sin A is equal to B by sin B is equal to C by sin C is equal to 2 capital R, right?
Yes.
So C by sin C is 2 capital R, so 2R cos B, right?
Mm,
So basically now I know in triangle OBH, BHO, I know this distance is 2R cos B.
yeah.
And I know this distance is R, right?
Yeah.
And I can find this angle because I know the other two angles. I know this angle and I know this angle also, right? See, this is
Oh,
circumcenter. So isn't this 2 times A?
yes.
So this is perpendicular bisector. So this must be A, right?
Yeah.
And this is isosceles triangle, this and this, right?
Yeah.
So
Yes.
if your vertical angle is 2A, so the other two angles are 180 minus 2A divided by 2, right?
Yeah.
So this part is also 90 minus A.
Yes.
So 90 minus A here, 90 minus A here. So I know the middle angle now, right?
It-
It will be this.
yeah.
So it will be 2A plus B minus 180. But 180 can be written as A minus B minus C, right?
Yeah.
So you get this, A gets cancelled, you get A minus C.
Oh,
So this angle is A minus C, right?
yeah.
I know the two sides here and I know included angle. So I can find OH
Mm,
by cosine rule.
yeah.
You can say cos of A minus C is equal to 2R cos B whole square plus R square minus Y square by 2 into 2R cos B into R, right?
Yeah.
And you can solve for Y here, correct?
Yeah.
It looks annoying and all, but it can be done. Okay.
Yeah.
You can solve for Y. Y is this. So if you know Y, which is OH, our OG is 1/3 of that by property of Euler line, right?
Yes.
Okay. So OG will come out to be 1/3 of, if I remember correctly, that distance is R root over 1 minus 8 cos A cos B cos C. You can search online right now, only you can search. Find the distance between O and H, where O is circumcenter, H is orthocenter. Just search online once
Um,
on Google or not. In any triangle ABC, OH distance.
OH squared. Oh, no, it's only that. OH is equal to R times square root of 1 minus 8 cos A cos B cos C.
Hmm. So this is the derivation. The derivation, I showed you the steps. That's what we do to simplify and get it.
Yeah.
We basically isolate the triangle and we try to do cosine rule in it. So we need the two side lengths and the included angle, right?
Yeah. Yeah.
So that's how that proof comes. Now we know OG exact distance. But in this
Mm.
problem, the thing is that I don't really know what he wants. Like, it's very unclear what D really is. Find the largest value of D in terms of OG such that D less than R. But D feels like it is always less than R, no?
Yeah, I think it is always different.
Largest possible value of D in terms of OG. And we
So
need to make mod of D less than R. D less than R. Largest possible value. So for that, is it possible that the square root becomes 1 sometime?
uh, when it comes,
Any one of the causes is 0, right?
yeah.
If it's a
So
right angle triangle, right?
yes,
Correct.
yes,
Otherwise, this square root is always less than 1, right?
oh yes,
Correct.
yes,
So we can say OG is less than equal to R by 3, no?
yes,
And POG is less than equal to R.
yeah,
So that will satisfy this condition and D can be 3 OG, right? Maximum.
yes,
Do you understand what I'm saying?
yeah,
So by Euler line property, I have found OH distance, which is the distance between orthocenter and circumcenter, right?
yeah,
That OH distance is R times root over 1 minus 8 cos A cos B cos C.
yes,
And if I know that, I know that OG is 1/3 of that
yeah,
because the 4 points lie on the same line O, N, G, C. Here C means circumcenter, G centroid, O is orthocenter here. Don't get confused.
yeah,
And it's the rule that this is 2:1 ratio.
yeah,
So if I need this distance, it's 1/3 of the total.
yeah,
So 1/3 of the total, right? And
yeah,
what I'm saying is, obviously OG is less than R. That's not a problem. What we are doing is, can we make the square root as big as possible? Or 1.
yeah,
That is possible
and
if one of the angles is 90, right?
yeah,
In the right angle triangle case, we'll get OG is equal to R by 3.
mm,
Correct?
yeah.
Other cases, this square root is always going to be smaller than 1, I think. Right?
Can wait, can
Equilateral
you?
triangle, it is becoming 0, see?
Yeah, yeah,
So it is smaller than 1, no, mostly. Always.
yeah,
So
and
we say that this is less than 1, therefore OG is less than this, right?
yes.
So 3 OG is less than R, and you can say D can be the maximum possible value is 3 OG, right?
Wait, what if one of the angles are greater than 90?
Then
Then,
it is bigger than 1, you're saying.
yeah,
One sec. Uh, but if let's take a certain situation, A is 120 and B and C are 30, 30,
yeah,
right? So cos A is minus half and root 3 by 2, root 3 by 2, right?
yeah,
Multiplied by 8 So this cancels. This becomes 1 plus 3, right?
Yeah.
4. So you're getting 2r by 3. Okay, so in that case, it is getting bigger, even more bigger, right?
Yeah.
Hmm. 4r by 3. So then this doesn't work. I'm not sure about what the D he means only. That's why there is a problem. Like, you can write whatever you've thought so far. Like, I'm sure
Yeah.
they will give you some points for trying.
Yes.
The first two are done. This one is not done fully because the question is only not very clear.
Yeah.
Question number 4, that functional equation, did you find any solutions?
No.
So I have found solutions, but I don't know how to prove that there are no other solutions. That's what is problem. So that for n is greater than equal to 1, fn plus 1 is equal to f of n plus 1 plus gif of f of n plus 1 by n plus 1. So the first thing that I thought was ki how to make it work. So I tried f of n is equal to n minus 1, and that immediately works. You can see when you do n plus 1, what happens? N is equal to n minus 1 plus 1 plus n by n plus 1, right?
Oh, yeah.
See, this is lesser than 1, right?
Yeah.
So this becomes 0 and it is fitting, right?
Yes.
The problem with this solution is that the function was defined from n to n, but then f of 1 is going to be wrong,
Yeah.
right?
Yeah.
So f of 1 doesn't fit here. So therefore this solution has a problem, but any other f, it will work, right?
Yes.
So then you can look at similar situations which don't have this f of 1 problem, right?
Yeah.
F of 1 should be also a natural number. 0 is not a natural number. So you can try something like this. F of n is 2n minus 1, right?
Yes.
In this case, f of 1 is also a natural number, right?
Mm.
So now let's try that. F of n is 2n minus 1. So n plus 1 will be 2n plus 1 minus 1. So 2n plus 1, right? Is equal to f of n is 2n minus 1 plus 1 plus GIF of f of n plus 1 is 2n plus 1 by n plus 1, right?
Yeah.
So now if you think about it, this is giving us 2n here. And if you look at this, it is n plus 1 plus n by n plus 1, right?
Yeah.
So that is
Oh,
1 plus n by n plus 1,
yeah.
right? So that can be written as 1 plus fractional part of n by n plus 1, right?
Yeah.
So 2n is already there. You get a 1 from here. So 2n plus 1 is coming, and this fractional part is always 0, right?
Yes.
So this satisfies, right?
Yeah.
And actually, you can show that any Cn minus 1 will satisfy.
Oh, okay.
You can just show by trial and all, you can prove that for any Cn minus 1, the C is a constant, right?
Yes.
The same way that we got this, you can try and get this also, right?
Yeah.
What I am not able to do yet is prove that it doesn't work for any others. Like I have not been able to prove that it is a unique, this is the only solution.
Yeah.
Do you understand what I'm saying?
Yes.
So you can do a little bit of work and prove till here and get the solution, at least some solutions you will have, right?
Yeah. Yeah.
Then you can say that I'm unable to prove uniqueness and all or something,
Yeah.
right? Because I have not been able to get why nothing else works so far.
Yeah.
Okay, just write it up properly as much as we have done. So then you can, and you also discuss it with Noah so that he can also
Yeah.
write his own solutions.
Okay.
I have recorded the class. I'll share the recording with you. You can look at it.
Okay. Thank you.
Fine. That's all for now then.
Okay. Thank you so much.
Hmm.